Following on from the previous video, I gave you this. I asked you to integrate this, and I said that there were two possible routes. One is to let u equals this. The other route would be to let u equals this. And by letting u equals this thing here, it gave us a messy answer. It gave us this answer here. And should you need to use this to solve other problems, then this here is really messy. It doesn't make your life any easier. Now, if you take this route, it will give you a much cleaner solution. So, as a rule of thumb, try to make u to be the simpler of the two. So here you've got a choice of making u equals this or making u equals this. As a rule of thumb, choose the simple one. Choose this one. Okay, so this one here. So making u equals this would give us this messy solution down here. And should you need to make use of this, then your life will be a lot harder. If you make u to be this, then your solution will be much cleaner. So now we are going to look at u being equal. So now we are going to look at this root here. Okay, so hang on. So let's try and do this, but this time make u equals the square root of x. Now if u equals the square root of x, then du equals this thing here, then multiply this to both sides. That will then give you this. So well, looking back at this, you square both sides, that will then give you this. So now we can put this into here. We can put the u into here, and the dx here, we can put this into here. But the thing is, we don't want the x here. So looking at this, so this thing here is actually in here. Okay, so this whole thing here is really 2u du. Well, substitute everything in here, it will then give you this. Okay, so now we are trying to integrate with respect to u, and everything is in terms of u. This whole thing here is in terms of u. Tidy this thing up. So this is a constant, take it out. This times this will give you u to the power of 3. So that will then give you this. So now it's a matter of integrating this. So now we have to use partial fractions. Remember this, the degree of the numerator is bigger than the degree of the denominator. So use long division. So using long division, when you get this divided by this, it will give you this solution with the remainder of -1. So we've done this in the past. So use long division, and you're, hang on, looking at this here. Whenever the degree of the numerator is bigger than the degree of the denominator, use long division. So using long division, if you get this divided by this, then the answer will be this with a remainder of -1. So now we can rewrite this thing here as this. Okay, because we've got our solution here with a remainder of -1 of -1. Okay, so that will then take us to this stage here. So now integrate this. It will then give you this, and when you integrate this, it will be the natural log of the absolute value of u plus 1. Okay, so integrating this will give you this. So now multiply everything out. So that will then give us this. And then earlier we said let u equals the square root of x. So now we can put this square root of x into here. So that will be well, visualize the square root of x as to the power of half, and then you got to the power of 3 here. So this times this will be to the power of blah blah blah. It will then take you to here, and then looking at this here. When you look, we said let u equals square root of x. Well, the square root of x is always positive, so we don't really care about the absolute sign here. So it can be this. Okay. So overall, the answer here, you see, this answer here is much cleaner than the other answer, And should you need to make use of this to solve some other problems, this here is easier to work with than the other one. Okay?